So this is our last bit of new notes. We'll start into like review mode tomorrow. I know, yes, this has been kind of a long unit stretched over 2 years. So what's that? So this is just like more problems, I'll say, more types of problems. Yeah. It's not a bad idea. I think we're only going to do two new problems, and then we're going to look at a graph of f prime problem, which is something that's within the the limits of something I can show you guys, and then I'll probably just give them some practice then. Okay, so we're going to do one actually very similar to one we saw last night first. So that is we got another farmer here. That's right. A farmer with 750 feet of fencing. Okay, wants to enclose a rectangular area. And then divide it into 4 pens.
Why not pencils?
I don't know, yeah. Why? And then divide it into 4 pens.
Divide those 4.
Or you'll get ink everywhere.
And then put a roof on it and put 4 more pens on top.
Calculate the surface of the sun.
Okay. Oops. Sorry. With 4 pens. Sorry, I should have said.
No.
With fencing parallel to one side of the rectangle.
Now I have an unnecessary comma in my pen.
You're welcome. With fencing parallel to one side of the rectangle.
Are they 4 equal pens?
So we assume so symmetrical?
Yes, 4 equally sized pens. Yeah. What is the largest possible total area of the 4 pens?
Alright, let's do it.
Okay. So we first really should maybe draw a picture here, okay? Because it might not be exactly clear about what I mean by that parallel to one side of the rectangle deal.
Oh, man.
Okay, have fun, guys.
You just couldn't take it in.
I know, right? Later, nerds.
Are you going to the aquarium?
It's a really big toilet. Okay.
Miles, like, I went to the biggest aquarium, like, what's that, the ocean?
Okay.
Anna's like, but is he really going to the bathroom?
Let's draw a picture here. Rectangular pen.
Oh, is it just like what I imagined?
Okay, and we're dividing it into 4 pens. Now, you might want to think, oh, then we just like cut it into fourths, like this. No, okay. The fencing is parallel to only one side. Well, actually, it's really going to be parallel to 2 sides, but the idea is like this. We're dividing it kind of like this, or like that, okay? That's right, you got to be careful there. Why is that important? Well, why did he do that? Well, maybe he wants some, I don't know.
Longer end.
Farmers not necessarily dumb. Farmers actually can be very smart people. See? I mean, right, exactly. No, but seriously though, like if you need to do something, you go talk to a farmer, and chances are they'll be able to figure out how to do it. Okay, they know a lot,
All right,
okay?
farmer, calculate the mass of the sun.
So, now, that being said, all right, this obviously, yes, it's kind of a strange situation. But just because we can't think of a reason for it doesn't mean that it couldn't, it could be stalls or something, right? I don't know, okay? So anyway,
Mr. Wade coming into the defense of the imaginary farmer.
well, just because we can't think of a reason doesn't mean it's not necessarily
It's math,
impossible.
it's fun.
So, I do anyway, okay, yeah, so. Here we go. So we want to come up with then, some equations here, right? So, all right. Christian, what are we trying? What's going to be our primary equation here? Or what concept is the thing that we're going to use for our primary equation?
The area.
The area, right? So we're going to find the area of this thing. So area is the primary, because we're trying to maximize or minimize that. So area equals. Now, we could call the whole side here x and the whole side here y. But then that means each little individual stall here would be x over 4, and that would kind of create like fractions and stuff like that, and I feel like that makes it a little bit trickier to set it up that way. Okay, so again, the idea here is like there is some freedom in how you set these things up, how you label them. You could label this entire side as x and this entire side as y. If you do that, the area is very easy. It's just x times y. Okay? Then when you go to do the perimeter, which is the the secondary equation we need, each one of these little pieces, well, I guess it'd be x and then 5y. I don't know. Maybe, I'm trying to think now.
I set it up as 4x plus 2y equals 750, and then x times y equals a.
Will be 8x.
Yeah. I don't know. I mean, we could do it that way. Let's just try it that way maybe. So let's just call this x.
Oh, yeah, that's funny.
It's
I
5,
had
it's 5,
X right
it's
here.
5x, not
I had
4x.
X right here.
Let's just call that x and that y then. Okay? So the whole thing there is x and y. So the area is just going to be xy, right?
Yeah, you agree.
Did you call the individual ones x? So then your area would then be 4xy. It's still going to end up being the same,
5, there's 5.
Well, you have it labeled differently than he does. It would be.
Oh, yeah.
Oh, so again, did you label this x, this x, this x, and this
I
x, right,
had
Emma? So it would be then 4x times
Yeah.
y, yeah. So you can do it that way, and it should end up being the same thing. So if you want to just follow along with this, Emma, you should be able, should be the same thing, okay?
Yeah, but that's assuming like the fence has a width of like 0. So like in a real world application, that wouldn't make sense.
Well, again, it's like,
Both sides.
the idea is the fence is going to take up an equal amount of space anyway, so you can kind of like ignore it. I mean, yes, you're not going to the exact area, but, again, at some point, we have to, we're also assuming the fence is going to be exactly perpendicular to the ground. We're also assuming we're able to make a straight line with the fence. So, we're making a lot of assumptions here if you really want to say that. So at some point, you have to say, all right, enough. We'll just say it's this. Okay. Secondary equation, we have 750 feet of fencing. Okay, so we're going to come up with a perimeter here. All right, so what would the perimeter, or what would that kind of secondary equation look like here, Austin? What would that setup look like?
Well, I labeled all of my individual sides to X.
Okay, so you labeled all these individually X. Okay, so
But
the
it
way,
would be 2X plus 5.
yeah, so for me, the way I have it set up here, it would be 2 X's, right? 1 X on this side, 1 X on this side,
Plus 5.
and then, 1, 2, 3, 4, 5 Ys I have to have in there. Okay, yes, if you labeled each of these individually as X, then that would be 8 X's plus 5 Ys. Okay, and actually in the time I did this before, I did that. I did each individual one as X. And then went from there. Okay, question?
Why do we count all the individual ones in the middle, when isn't the perimeter should be outside of the fence?
Okay,
You have to put fencing.
the fencing goes in the middle though, too,
That's what separates it.
for the pens, yeah.
Yeah, but, so, I can see what you're saying, but like, is that really the perimeter?
So you're right, I misspoke. I shouldn't say the perimeter, I should say maybe our constraint, our secondary equation is just the amount of fence that we're using. So we can use at most 750.
Okay.
You're right, it's not really the perimeter then, yeah. And it's kind of the perimeter, it's the perimeter of like the individual, pens, and there's 4 of them. But yeah, it's better to maybe not say perimeter there, it's not exactly perimeter. Yeah. Shh. Guys, too much talking right now, you should be listening. You might not even realize you have this question that Donovan's asking. You might go, oh yeah, that doesn't make sense, why is that? So. Yeah, so, I mean, it depends, okay? So you could be given a question where it's like, you want to figure out the maximum area, you only have, and maybe you're using two different types of fencing. One type of fencing for the, you know, the actual perimeter, and then a different kind of like fencing for like just the individual stalls or something. And so, yeah, you'd want to separate those kind of two things out, and then you might, yeah, it depends on the situation. In this case, we're using the same fencing throughout, and so it's $750 for the total thing, for all the pieces, all the boundaries, all the borders, okay? So, solve one of these here for a variable. It doesn't really matter which one. So, I don't know, I'll solve it for y, I guess we'll say here. So we get 750 minus 2x equals 5y. If you solve for x here, though, it's going to, you know, be just about the same thing. All right. 750 divided by x is 150 minus 2/5 x. Right? Okay. And so I'm going to take that and plug it in over here into my primary equation. So A equals x times 150 minus 2/5 x. Okay, we'll distribute that x there. So I get A equals 150x minus 2/5 x squared. Okay. And so, Emma, at this point, we've simplified our area. Now what do we need to do? Take the derivative. Exactly right. Okay, so we end up with 150 minus 4/5 x. And then what do we do with the derivative there, Emma? Set it equal to 0. You got it. So 0 equals, 150 minus 4/5 x. So 4/5 x equals 150. Okay. And so we get, 187.5?
Yeah.
And that's in feet. Yes. If you don't label it with like the units or whatever? So it's a good question. Sometimes units do count, sometimes units don't count, okay? And I can guarantee if it says, if the directions say, make sure to include correct units, then the units are a point. Even if you get the number wrong and you have the correct units, you get that point. So you mess up your calculations, you still put that, feet there, you still get it. If you put I think if you can put like just like a random number and feet, there's a chance you can still get that unit point, because you know what the unit needs to be. If you tried something, you made it look like you knew what you're doing, or you tried something, and you end up with the answer in the correct units. Yeah. Yeah, because I'm pretty sure that's how they grade it. So I mean, don't just give up. Try to get those points when you can. But then beyond that, Anna, I can't really say. Sometimes there are points, sometimes there aren't. But if it says make sure to include correct units, you can guarantee you get a point for units. Yes, Emma. You did the individual x's, right?
Yeah, so did I have to change my secondary equation to that?
So, yes, your secondary equation then, because you did individual x's here, it would be 8, because there's 4 x's and 4 x's here of fence, and then 1, 2, 3, 4, 5 y's. Did you not change it?
Yeah, I didn't.
Oh, okay, I'm sorry. Yes, it should be 8x plus 5y. So that should be a pretty easy kind of change there. Just change all the 5s, change all the 2s to 8s. But anyway, you end up with 187.5. You should end up, Emma, with 46.875 when you when you do it.
Yeah, I got that.
46.875. Okay.
So why are they different?
Why are they different? So good question. So I got
Because your total length, yeah.
exactly. So the 187.5 is the total length. For those of you that did these individually as the x's unto themselves, well, there's 4 of them, so this divided by 4 would give you then your 46.875. Okay. Plug this back in then up here to get the y, so y equals 150 minus 2/5 times 187.5. Okay, I'm just going to type that in my calculator. $75. Okay, so y equals 75 feet. Okay. Did we answer the question that was being asked? No, we did not. Not yet. We found the dimensions, but in this problem, we're not asked for the dimensions. We have to find them, but we want to find what is the largest possible total area of the 4 pens. So we got to find that total area. Well, and this, again, with the way I have it set up, it's going to be just x times y. So my final step here is I have to do area equals 187.5 times 75. Sorry. Okay? My area is just x times y. Again, for Emma, for example, Emma's yours would be 4x times y because of the way you have it set up. Okay?
Yeah, I just changed my back page.
Oh, but you really could have done it. You just missed. There's just one little difference. That's all. So 14,062.5 square feet. Right. Okay. So that is our final answer. That's the maximum area we can make with those 4 pens and that constraint of fencing. Okay? Questions on any of that? We're going to do one more otherwise. One more. Uno más. Okay. An open box is formed by cutting squares of equal size. Actually, it's an open-topped box, but anyway. An open box is formed by cutting squares of equal size from the corners of a 24-inch by 15-inch piece of sheet metal and folding up the sides. Okay. Determine the size of the cutout that maximizes the volume of the box. Okay.
So basically, you have like a piece of sheet metal. You cut out squares from the corners
Mm-hmm.
and kind of throw those away.
Mhm,
Fold it,
discard them,
and then
yep.
you fold it up.
Yep, exactly right. So we have our rectangular piece of sheet metal that we start with. It's 15 inches by 24 inches. Okay, and when we cut out those corners, then I'm going to try and like okay. We would then fold up along these edges right here. So that's kind of inner rectangle will be the base of our box, and then we fold up those sides to create our box. Maybe like a weld or something like that to seal the corners. Okay, and the shapes that we cut out there are squares. We cut out squares. All right, so that's the idea. we don't know the size of those squares, so that's it's kind of unknown to us. So we can call those like x, for example. We want to determine the size of the cutout, so we'll call all these little cutouts here x. So if that's x, that'll be 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 x. All those little cutouts we cut in, x inches, I guess we're going to say, x number of inches for those squares. And they're x by x squares. Right. Remember though, the original shape, the original size of this piece of sheet metal was 24 inches along the bottom here, right? And 15 inches for the top. Okay? So there's kind of our setup. Okay, so some of these, that's like half the battle right there, is just making sure you get it set up correctly. All right. What is our primary equation? What's the thing we're trying to maximize or minimize here? Volume. So primary equation, and again, you don't have to write the word primary if you don't want to. I like to do it just for organization's sake, but there's no points ever assigned to something like that. It's just for organization. So volume equals, all right, what will the dimensions of this box be? Okay, so yeah, the length here, or this width or length, whatever you want to call it, is going to be 15 take away 2x, right? 15 is the full length, but we're cutting in x from each side, so it's going to be 15 minus 2x for from here to there. And then for the other side of the rectangle, it will be 24 minus 2x.
And then our height will be x.
And then you're right, the height is x. Okay, because these cutouts, right, they fold up to then create the height of our box. So this x here is going to fold up and create then that height of the box. So it'll be base times height. So 24 minus 2x times 15 minus 2x times the height, x. Okay. What is our secondary equation here?
Derivative of
There isn't one. We don't need one.
yeah, there's only one.
We don't need one, do we?
There's only one variable.
There's only one variable. We don't need one. That was a trick question. Sorry I did that, but just to make sure. Because we've done so many of these, all the ones we've done prior to this have had secondary equations. This one's like really messy looking, so we're like, oh, messy ones, weird ones, we have to have a secondary equation. Well, actually, we don't need one here. It's all in terms of x. So now what should we go about doing?
Derivative.
Yeah, do we want to take the derivative right now?
Simplify first.
I'd rather not, right? Yeah, let's distribute the x. That's a good idea. Let's distribute that x. We get 15x minus 2x squared. All right, we could take the derivative here, or we could FOIL it out and then take the derivative.
I'm a foil.
I like to FOIL this one. In the past, I did the product rule, but
Yeah, it's messy.
I'm gonna FOIL it. So let's just FOIL it here. So let's see here. Yeah, I'm gonna do my calculators on this too. So 24 times 15. So 360x for the 24 times the 15x, and then 24 times minus 2x squared is minus 48. And then 2x times 15x is, or negative 2x is negative 30x squared, and then 2x times minus 2x squared is plus 4x to the third. Yeah, that makes it a lot nicer. Connor, have I taken the derivative yet?
No.
No! Very good. But Connor, what should I do next? Now we take the derivative, and I'm going to write v prime. Okay, for all of you guys that are too lazy to write something here, and you just magically take the derivative on this side but never indicate it, you will lose points on my test and on the AP test if you don't label things correctly, okay? You're able to not put the v for these steps because we're still talking about v here and here. But for this one, now we're taking the derivative, you have to indicate this thing that we're showing is now the derivative. Don't be lazy. Okay, so let's see here. 78 is 156x, and then plus 12x squared. Whew, and now he said that equal to 0, right? And is there anything we can do to help start simplifying this right-hand side? I think, yeah, we can see, let's see if 12 divides there. So let's see, 360 divided by 12 divides evenly, 156 divided by 12 divides evenly. So let's pull a 12 out. So I get 30 minus 13x plus x squared. And let me flip that order around because I don't like having the x squared term at the end there. So x squared minus 13x plus 30. Okay. Does it factor?
Yes.
Oh, 48.
So we need two numbers that multiply to make 30, but add to make negative 13.
Those aren't the right signs, but those are the right numbers.
Right, that would work, but unfortunately, yeah, it wouldn't. 15 does multiply times 2 to make 30, but then it would be, we need them either to be both 15, positive 15 and positive 2, or negative 15 and negative 2, but then they wouldn't add to make negative 13. But yes, negative 3 and negative 10, they would work. So you weren't wrong. Well, I mean, you're on the right path, though. I mean, that's how you have to do it, though, Mac, is you kind of guess and check. You just see. You don't have to get it right the first
Well,
time.
usually there's like not another set of numbers that equal the same thing.
Oh,
So
right.
like 15, too, that's 17.
Right.
Okay, I'm getting.
So we get x equals 3 and x equals 10. We have 2.
Oh, you gotta analyze it.
We gotta check it.
Right, okay, so let's check to see if both these make sense. So one way we can do that, right, so you can go back into V prime. Okay, we can go into V prime and C here, so we can go to our number line. Let me see, am I going to fit this? Yeah, I'll fit it, okay. So I'm going to make a little number line over here, V prime. Okay, we'll put the 3 in, put the 10 in. Okay. So to the left of 3, what number should I pick?
1.
Yeah, I wouldn't pick 0 here, right, because we wouldn't really be making a box then. So let's say 1. Am I moving too fast? I need to slow down? No? Okay. And then we'll pick like V prime of 4, and I'll pick V prime of like 11. Okay, now, when I go to plug this back in, don't forget there's that 12 there, that coefficient we pulled out front, right? So don't forget there's that 12. Now granted it's positive, so it's not going to really affect things, but if it were negative, right, that would affect things. So you always, don't forget that coefficient you pulled out. Just because we could divide it by, divide it over and stuff like that, it's still part of the derivative. So anyway, let's plug in 1. 1 minus 3 is negative. 1 minus 10 is negative. 12 is positive, so it's positive times a negative times a negative, so it's overall positive. Okay, we try 4. 12 is positive, 4 minus 3 is positive, 4 minus 10 is negative, so positive, positive, negative, negative. And then V prime of 11, 11 minus 3 is positive, 11 minus 10 is positive, times 12 is positive, so it's positive. Okay? So, what is the size of the cutout that will maximize our volume? 3, okay? Now, there's another way we would be able to convince ourselves here that 10 is not going to work. Can anyone see what's another argument we can make here to convince ourselves that 10 is not going to work?
Oh, would that cut too far?
It would cut too far into the box, yeah. If we only have 15 inches to deal with here, if I cut in 10 from this side and 10 from this side, that's, I don't have any box left. It's just, right, yeah, exactly. It would work here for this one, but not for this side. We could do it for the 24. You have a 4-inch, but there'd be nothing. So, we just are in a little number line. 10 goes minus plus. That means that's a minimum there. It'll be the smallest volume box.
Scrap metal machine.
Right, yeah. So, all right, the cutout. Okay, that maximizes the box volume. Okay, is a 3-inch square. You're welcome. Okay, 3-inch square. All right, questions on any of that? All right, then I have a little review kind of problem for us to look at. All right, so this is now we're going to change gears and we're looking at something that we will be needing to have covered or ready to go for our test. Okay, we're going to look back at a graph F prime problem. Okay, so I'm going to kind of give this to you cold. I want you to try as much as you can with this, A, B, C, D. Okay, get as much as you can done with it. If you want to look back at other stuff, feel free to. I'm going to go run and make some copies real quick while I'm doing this, but I'm gonna leave this up for you here, so I want you to try and like wrestle with this some. Okay, this is a graph of f prime. Okay, so just on, you know, if you want to like sketch it out or something like that, this is what I want you to try and do, okay? I will tell you right now.
Is that a scale on a scale of 1?
Yep, it's counted by ones. I know it's hard to see. It is counted by ones, though. I will tell you right now, this is a very popular free response question to show up on the AP test. And so, what's the problem?
4 is 5.
Yeah. No, it's because it's down,
Oh, okay. I thought it was saying at where it intersects is 5, -1. I didn't see it. What do you
Yes, no, the end point is 5, -1, and then that other point there is 2, 2, and then all the other points are obvious because it's on the x-axis there, so. And the intersection point, the 0 there is at 4. It intersects at 4, 0. There, so 5, -1, that's 4, 0, and 2, 2. So go ahead, tackle that, okay? I'm going to go make some copies real quick for us in the meantime, but please do.
Is that supposed to be F prime there, or is that F versus what F be?
F is a function to find a closed interval. So give this a shot. Okay, so my conclusion was what I was trying to get to there, sorry, before I, ask the question. This is a very popular type of AP question that you see for a free response on the actual AP test. It will very likely be a type of free response question you will see for your upcoming test. Okay? Like the only kind of the only problems we really saw with graphs F prime were all free response style questions. So yes, it could show up in a multiple choice, but it's also very likely a free response type question to expect for your test too. So you want to make sure you got this down. Oh, Michelle, right?
Why don't teachers just say this is on the test? It's very likely. Highly probable. Just get tested like nothing on it. There was a low probability. Point of inflection? That's where the graph of F prime changes from increasing to decreasing or vice versa.
Would the .22 be one of those?
Boy, I don't know. What? Yeah. Find all values of x. Relative maximum.
Wait, -5 is not changing, right? It's just there.
Walk and then.
Why would X equal negative 3?
When f of x changes from
Maya, did you get your ornaments? They're in the corner of the room.
So it changes from positive to negative and negative.
Yeah, Connor, your ornaments are over there too, and nobody's like it.
No, I don't think.
ones because they don't work half the time.
I don't think x equals 2 is a point of view.
Why not? Just from increasing to decreasing.
Yeah, but it's not differentiable.
Boy,
It
it was
would-
fine. Doesn't matter. It's differentiable. It's when the derivative is 0 and fine. Fucking head ass.
Yeah, I know.
Fucking head ass. Boy. And also has a positive slope. Okay, so that's where it's increasing and positive.
X is negative 1.
Hill or valley.
Negative 4, negative 1. It's 2, yes.
I've never actually.
I don't know if 2.
Yeah, my brother.
But it's not a hill. I don't know why.
So you're saying 2 isn't? Or are you saying it is?
I don't really mind it.
I guess it is. I honestly don't know.
I've noticed every time. You think Tyler would take it off with the lawnmower?
Wow.
What do you say? You can't say because the project is a.
Good to start it.
Yeah, that's why, no, that's why Wanda was like, how you have to press a button when the newer one, to back up, when the is still going, you know? You have to press a button.
Yeah.
Yeah, because a guy ran over his daughter.
I know, but there's.
Yeah.
Oh, where's she? Oh my gosh.
Very good.
Yeah.
Like,
That would be really
Some folks think some shit else.
I know, Errol.
Who, Matthew Sager? That's immediately what I thought of, Matthew Sager.
And also,
like, negative. Or like,
Oh,
so maybe X equals.
That's right.
It does, yeah, I agree. What's the
So it has to be increasing.
Find out all those unless your graph of S is
Okay.
explain your graph. Wait, yeah, you got something to do with this, yeah.
Oh. So it's negative
S
5.
prime.
Yeah, so negative 5 to negative 4. For a lot.
And 1 to 2.
Negative 5 to negative 4.
That's it.
1 to 2.
It's not concave at those points, though.
Yeah, you can
It
justify.
doesn't have to be that
Oh.
prime.
Yeah.
We done?
No.
I know.
I have a question.
You're crazy.
Does, for
What?
B, when.
You're wrong, bro.
Correct, yes. Yes, because it's not only when the second derivative equals 0, hill or valley, it's also when the second derivative is decline, which would be.
No, not negative
that
1.
way.
Negative 3, negative 1, 2.
That change from increase to decrease.
It's not negative
Yeah.
3.
Yeah.
Negative 4, negative 1, and 2.
Yep.
Wait.
It's, yeah, negative 4, negative 1, and 2. You said negative 3.
He originally said negative 4.
Any questions?
So it's where F prime changes from increasing to decreasing, not
Yeah.
negative.
Increasing and decreasing are
Okay, say that one more time. I'm confused about that.
That's relative extraction.
Which one you're trying to like look for? It depends on what you're being asked about. So which one are you working with right now?
It's increasing, so from negative 5 to negative 4 it's
So you're trying to find the relative maximum of
Yeah.
F. Okay, so forget the picture right now. Let's just like this is like fundamentally when I hear relative maximum of F, what do? We take the first derivative. We want to see when the first derivative is changing from positive to negative, which means the original function is changing from increasing to decreasing, right? So what do we? Okay, right? But look, we look up here. We have F
And
prime.
negative 5.
So given F prime, and we want to find the relative maximum of F, we look for where F prime is changing from positive to negative, because that means then F is changing from increasing to decreasing. You understand? So for example, negative 3 is the relative maximum of F.
How do we justify How do we justify D? How do you do D? Well, I know how to do it.
It's more like explaining your reasoning.
Yeah.
So, find the absolute minimum value.
It's like,
You said 1, I'm assuming, right?
yeah.
So, and again, it's hard now without having done integrals, so
I just said that like a net decrease.
don't worry. Basically,
How do you figure
yeah.
out that it's 1?
Well, again, the way you can kind of like justify it is
Look
just
at the
look at the
area.
areas, exactly.
Oh.
So this positive area will be canceled out by this negative area, but then, and these are all nice geometric shapes too.
Yeah.
They did it on purpose, so you
You
can
can look at it.
actually find it, but don't worry about that right now. Just the fact that you can identify it.
Okay, so if you go to
Yes,
that means.
at
I
1.
just want to. Yo, Anna.
You could if you wanted
What
to,
was-
but I
what
can
was
also
like-
So yeah, negative.
Yeah, but what?
Oh, it's a negative 5.
One specific.
Yes. That's where F prime is an increase. Oh.
Yeah. Oh, are you doing?
Yes. Yes, negative 4.
Yeah, and then negative 1.
Negative 1 to 2. And then you use all of that. Question on it? Yes. Right. And, but it's not just where it
Ooh, geometry.
just where it needs to be five, so you have to change it. Possibly.
Boom Beach. This is like a new Clash class.
Yeah, but the logo.
Oh, yeah.
At the.
Yeah, it's the acronym of F, not F.
Should I get mad at mobile again?
Well, I think, because like, that curve is so much bigger than the curve above it.
Oh, wow.
Booby trap, that's okay.
That's not good for one.
I know. Oh, they're so tight.
You have a foam roller?
I do have a foam
Those things
roller.
are a gun.
They are nice.
I think it's one.
No,
I have a smooth
trying
one.
to find a new logo for my phone. Or not logo, a new background.
Yeah, no, you guys, I was watching what you were doing, I was like, nope, nope.
I hate
Bruh.
Do you even live?
Yeah, I told T-Rock and like one of the first things.
Oh, yeah.
That was weird, yeah. There was a lot of people there on Tuesday, though, after school. There was a lot of people. It was like, and what was Mrs. Warrenfeld doing up there with, softball? Is she coaching softball now? Oh, that's cool.
Baseball should have listings on Monday, softball should have listings on Tuesday.
Yeah, because baseball is going to look every day.
Okay. I'll give you guys like 2 or 3 more minutes here to finish up, and then we'll go over this.
Boy.
Okay.
Remember, let me beat this level 6 try. Here we go. Alright, let's do special.
Austin,
Yep, yep.
Austin, did you put the minimum was that one?
What? The absolute minimum?
I'm talking about you.
No,
So deep.
I think it was one.
Yeah, I have 1.
I mean, you can just kind of look at it. Is that like an app or is it like I download?
That sucks. Why? What do you use? I just find it very hard. I have like a bunch if you want to look at them.
I just Google whatever I want.
A lot.
Edit it.
Yes.
Like, how do you
In the gallery.
determine deep? I don't like, you just look at it, but I don't.
Right. The explanation, I don't want you guys to worry about right now. That's really something that's going to be more applicable when we talk about integrals. Like, it'll make more sense to explain
Look
it.
at it, no.
Okay.
The area of the...
It has to do with the fact that there are intervals where you can tell f is increasing. There are intervals where you can tell that f is decreasing based on whether the derivative here is positive or negative, right? So, for example, if that the first interval from -4 to -3, the function's increasing. So clearly -3 can't be locating an absolute minimum because it's going to be higher than wherever the function was at -5. Okay? But then from -3 we decrease all the way up to 1. You see that? And in fact, if you look at the amount of decrease, it's going to be greater than the amount of increase that we did there. So not only will 1 be lower than where we are at -3, 1 will also be lower than where we are at -5 because we've decreased beyond that, beyond a little bit of increase. So 1 looks like it's going to be the biggest, lowest. Then you go to the right of 1, we're now above the x-axis, so certainly 1 still will remain the lowest from 1 to 4, and then to 5 we have a small amount of decrease, but not enough to cancel out the amount of increase we just did, so 1 is the absolute minimum. Okay, now obviously that's a lot to write down and justify, and there's a better way to justify it using areas of the faces on the curve, and you can see they're nice geometric shapes too, on purpose. This would be like a non-calculator free response question here, because you have all the nice geometric shapes to help you answer the question. So, all right, so let's just take some time here to look over these answers. Okay, I heard a lot of good discussion and stuff, so that was really encouraging to hear, especially with the test coming up, and we haven't talked about problems like this in a while. Some of you guys looked at your notes, and that's okay. Just make sure you understand that you won't be able to use your notes later, so you want to make sure you have it down. Okay. So let's take a look here. So number 1. All right. Actually, that's a bad idea. I should do this. We always want to make sure you read this little paragraph here up top. Okay. So the reason why I say that is because sometimes there is important information included in here that we otherwise would not, that we might need to use in these problems, okay? So for example, we're told that f of 1 equals 3. That could be significant here, so we don't want to just like gloss over this information, go right in here. Read this here and like understand that, okay, this is a typical thing we kind of see. It's like continuous over an interval, stuff like that. This f of 1 equals 3, that could be important though. That's a point of our function. The graph of f prime, derivative of f consists of 2 semicircles and 2 line segments there. So that kind of helps you know you can make the geometric shapes there. Anyway, letter A, find all values of x at which f has a relative maximum. Justify your answer. Okay, I have a volunteer that wants to give me that one. Okay, so Emma, I saw your hand first, and most enthusiastically, so...
Max 2.
Max 2? All right, we'll see. I saw Emma's first, though. Sorry, Max. Okay, you probably did them wrong. Great, and then we'll go to Mac then, and she'll correct you, okay?
We're on A, right?
After you stop laughing, yes.
4.
Okay.
Okay, x equals 4, you're saying? And x equals negative 3. Mac, do you agree?
Yeah.
Darn it, she's right. All right, Mac, what's the justification? Why?
Because, f prime of x changes from positive to negative
At those points, okay? Yes, perfect. That's an excellent justification. Yep. I'm assuming you had that justification too. Same thing. F prime changes from positive to negative at that point. Okay. What's that? You forgot the justification? All right, so, you would have lost points then, for sure. If it says justified, that means there's points attached, okay? So don't lose points for something like that. Silly points to lose there. All right, let's go to... All right, Connor, I see the hand there. I didn't get to ask questions. So letter B, Connor.
Okay.
Point of inflection.
My points of inflection I got at x equals negative 4.
Negative 4.
At x equals negative 1.
Negative 1.
And at x equals 2.
Very good. And 2 as well. What was your justification for those?
I said when the graph changes from increasing to decreasing slope.
Okay. Make sure you say the graph of f prime. I think you might be safe just saying the graph because this is the only graph that we've been given, so referring to it that way, it should be okay. But yes, that's sufficient, okay? That's all you have to say, all right? If you want to be really thorough, you can say, the graph of f prime is changing from increasing to decreasing there, therefore f prime prime is changing from positive to negative, therefore f is changing from concave up to concave down. But what you said is sufficient, I think, yes. Can you write on the board?
Yeah, I don't like the board.
Oh, I know, yeah.
It's like, we should write A and write our answers up there.
Yeah.
Maybe for like review or something like that, we'll do something, okay? Yeah.
Or not.
Prepare the unfair game. All right, letter C.
I want to feel accomplished.
Now here's an interesting one. This kind of combines two things. Find all intervals on which the graph of f is both concave up and has a positive slope. Explain your reasoning. I have a volunteer here. So awesome. We haven't
Alright,
had
I
you
said
answer yet.
f of x has a positive slope and is concave up on the interval 1 to 2, because on this interval, f prime of x...
1 to 2, okay, sorry.
Yep, f prime of x is increasing on this interval, and it's also positive on this interval.
Perfect, yes, exactly right. Are we okay with that?
Wait, not all the interval.
Yeah, that's not the only interval though, right?
Yeah.
So there's another interval. Where else?
-5 to -4.
-5 to -4 as well. That's right, Tyler. You got that too?
Yep.
Good. Yeah. So there's two intervals here. -5 to -4. F prime is both positive and increasing, and then 1 to 2. F prime is both positive and increasing.
What about that part, the current?
Right
Well,
here.
that's when you go to negative 1. Well, that's not, doesn't matter.
Okay. Be careful. First of all, here F prime is negative, therefore F will be decreasing.
That is so annoying.
Okay? So we gotta be careful with that. Now, this is concave up and has a positive slope, but we're not asked about where the graph of f prime is concave up and has a positive slope. We're asking where f has concave up positive slope. So, it is annoying. I agree, Mac. It's challenging, right? There's a lot.
Looking at graphs of f prime.
So it's a lot to remember. Okay. Try not to do it all at once. Try to break it up piece at a time. So just remember, okay, so for example, f concave up, that means f prime to be positive, which is where this would be increasing. So it's only this interval and then this interval. And then where the slope is positive, well, that means it has to be above the x-axis. Okay. And then letter D, find the absolute minimum, and it's at 1. You probably already heard my argument there for it, but it is at 1. okay?
Does that mean the entire graph is above 3?
So yes.
No, not that graph, the graph F.
Yeah, no, yes, exactly right. Yes, 3 is the minimum value. Oh, I guess I should say, okay, wow. So actually, guys, here, I need to correct something just subtle. Minimum value
Is the
means
Y value.
we're finding the Y value here. So if you gave your answer here for letter D, if you said the minimum value is at x equals 1, that's not correct.
I gave the coordinate.
And that's my mistake, because I didn't point that out. Okay, minimum value, you need to give me a Y value. Now, here's the thing. How can we avoid having to worry about whether I'm supposed to get the X value or supposed to give the Y value? Give the coordinate. Just say the absolute minimum occurs at 1, 3, boom, you're done. You have to justify it, of course, but, okay? I will not ask you guys to justify a question like this, okay, on the test, okay? Or if I do, the explanation can be kind of, it doesn't have to be as precise as we will have it be later, okay? Where does the Y go?